And you can't have a radical in the denominator. If you do, it's not the simplest form. So I think we're well on our way with this one. What do you guys think? So let's look at these two. Well, let's kind of go through there. So here's an example of a fraction inside the radical. You got a fraction inside a radical. It's not in simplest form. I'm not allowed to do that. We did talk a little bit about a property. We have a property that if you have a fraction inside a radical, you can split them apart. Just like we did when we're multiplying. When you're dividing, you can split them apart. So I'm going to take the square root of 13 over 100. And what's it going to change to? Square root of 13 over the square root of 100. I'm just splitting them apart. And once you split them apart, we use the skills we just learned. Simplify this and simplify that. And then you're done. So let's see, the square root of 13. Are there any perfect squares hiding in 13? No. Right? That's going to say. What about the square root of 100? 10. And I'm done. So now I no longer have a radical with a fraction inside. So this is fine. I can have this. What?
You have a fraction with a radical.
I have a fraction with a radical, but it's not this. It's not where I've got the radical inside there. Let's look at this one over here. I've got 1 over y squared. So what's my first step? Separate them. Let's split them apart. So I get the square root of 1 over the square root of y squared. Now let's look at each one individually. The square root of 1 is 1. The square root of y squared. Why not? Yeah. 1 over y. So we can reduce that radical. Now it's okay. Now it's in simplest form. Alrighty. I'm calling this a digression. Do you know what a digression is? You know what that means? Digression is I'm changing the subject, or so it seems. So yeah. So what I'm talking about something that doesn't seem like it's related, but it will be. So I want us to think about when you have a square root times a square root. That's this. If I have square root a times square root b, what is that the same as? Excellent. The square root of a times b. So if I have the square root of 6 times the square root of 6, what's that the same as? 6 times 6, right? Well, what is the square root of 6 times 6? 36, which is 6. Look at this. The square root of 6 times the square root of 6 is 6. Think about it for a second. Does it make sense? When I take the square root of 6, I'm taking the number that when I multiply it by itself, I get 6, right? Well, aren't I multiplying it by itself? Because this also is the square root of 6. So when you have the square root of a number times the square root of a number, you know what you get? A number. Like, what is the square root of 4 times the square root of 4? 4. So I need to say, well, that was 2, and that was 2, and I can do 2 times 2. No, it just makes sense. What about the square root of x times the square root of x? X. So this little fact's going to come in handy. It's going to help us out in a moment. Let's see if we can do ones like this. So if I see a product, how do I go about simplifying that thing? I've got this number over here. Remember, this is a product over here too. Everything I see here is being multiplied. So why don't I put the 4 out in front, and then take that square root 3x, square root x, and then what can I do with these guys? What can I do? I sure can. All under one radical. I can have 3x times x, which is 4 times, what equals in here? 3 times x squared. Split them apart, right? And what am I getting here? 4. Can I do anything with radical 3, or is that simplest form already? Simplest form. Square root of x squared. And if you look real close, some of you may see this. I have a square root of x times the square root of x. Doesn't it make sense that the x comes out? Now remember, those go in front. Everything outside the radical goes up front, and then the radical part goes there. So if you see a product, I think it's easiest to try and just put them together and see what we can figure out. So when I have one like this, Again, here's my 3. I'm going to put them up front first. I think it's a little bit easier to see. And now let's see if we can combine these. Now what about that now? What's x times x? X times x. X squared. Good. What am I going to get? Do I need to really separate them out? Can we see it? What's going to happen to the 7? It stays inside, right? There's nothing going to come out. Square root of x squared. Square root of y squared. So all I've got to do now is just put, the radical stuff on the other side. 3xy radical 7. And again, you might, if you can see it, that's really great. I've got a square root of x here times the square root of x. Square root of x times square root of x is x. So I could have maybe just taken it right out front when I see that. You get a little bit more used to working with this. So let's see what else we've got here. So anyway, I'm just going to go back here for a second. I'm done with this discussion on how you get a radical to not be inside a fraction anymore. So that was real simple. So that first condition was pretty hard. We had to work hard on that. This one is pretty simple. Just remember to pull them apart, and reduce each one. The next thing we're going to look at is the third and final part of simplifying a radical. Final part. So the last problem is I can't have a radical in the denominator. This is an irrational number. When you take the square root of a non-perfect square, it's irrational. I am not permitted to divide by it. Oh no. So I got to figure out how to turn this radical 7 into something that isn't a radical. Do you have an idea? Multiply by 1, but a special version of 1. Well, why are we choosing this? First of all, do we see why this is 1? Any number divided by itself, as long as that number isn't 0, is 1. Right? 5 over 5, 1. 10 over 10, 1. Square root of 7 over square root of 7, 1. So I'm just multiplying the fraction by 1, so I'm not changing the value of the fraction. But why did you choose such a crazy looking version of 1? And first of all, think about how we multiply. You multiply numerators, you multiply denominators. Let's focus on the denominator. What is the square root of 7 times the square root of 7? 7. Look at that, my radical's gone. It's just disappeared. It's the square root of 7 times the square root of 7 is 7. Now I have to do the numerator, right? Whatever you multiply the denominator by, you have to multiply the numerator by. So here's something I don't know. What is 5 times the square root of 7? 5 times the square root of 7. You're absolutely right. Oh, it turns out that's easy. So what you're basically doing is, how can I get rid of the radical? We're going to use that trick we just discovered. The square root of a number times the square root of the same number gives you that number. So what can I multiply by to get rid of the radical? As long as you do it top and bottom, you haven't changed the value. So even though I think this one looks actually more complicated than 5 over radical 7, this is the simplified version. This is where you go if you wind up with something like this. So let's see if we can apply it to this guy. I've got 4 over radical 2x. Am I allowed to have a radical in a denominator? Not in simplest form, I'm not. So how do I fix that? What should I multiply by? Yeah, because what's the square root of 2x times the square root of 2x? 2x, right? Comes out. But remember, I'm multiplying by 1. So if I multiply the bottom by the square root of 2x, I have to multiply the top by the square root of 2x. So let's see what's going on here. Well, let's do the denominator first. You already told me square root of 2x, square root of 2x. Well, it's going to come out. You get 2x. What is 4 times the square root of 2x? 4 times the square root of 2x. Here it is. Fantastic. Now, I can't leave yet, though. Why can't I leave? I mean, I want to be done, but I'm not done. How come? Well, let's see. I like cancel out. And she's saying, why don't we cancel out this thing here, this 2x, with the 2x inside the radical? Can we do that? Let's think for a minute. If I have, I'm just going to come up with an example. Square root of 4 over 4. Can I just cross out the 4's? Is this 1? Why can't I just cross out the 4's? Yeah, it's really 2 over 4. The square root of 4 is not 4. So is the square root of 2x 2x? So can I cross them out? Well, what can I cross out? What can I cross out? Yeah, these are both outside the radical. This is a 4, and this is a 2. What is 4 over 2? 2, right? So I have a common factor of 2. So this becomes 2 square root 2x. What's left on the bottom? Just an x. So yeah, you do have to cancel out, and you can, but be careful. You can only cancel out stuff that's outside, or you could cancel out stuff that's inside as well. So if I had square root of 2x over the square root of x, these actually do cancel out, because remember, that's the same as the square root of 2x over x. And they do cancel out. So stuff inside the radical can cancel out, and stuff outside the radical can cancel out, but don't mix them up. You can't do both one outside and one inside. So just be careful of that. Makes sense. Up, middle, down. Let's just you gotta make a choice. She's like up and down, up and down. All right, we're getting there. So these are the U tries. I'm just gonna do. Remember this big mess? I hope it doesn't look so bad. I'm gonna look at this guy over here, number F. Oops. Number F. Letter F. Letter F. What am I going to do? Do I want a square root 3 there? Oops. Can I have it in the denominator? Is that allowed? No, so what should I do? Square root of 3 over square root of 3. I heard it. So let's see what I get. What's in my numerator? What do I get in the numerator? And what do I get in the denominator? Done. Let's look at this guy. I'm looking at E. Am I allowed to have a fraction inside the radical? Split it up. How do I split it up? Square root of 9x up top. Square root of 16 here. Now I have to reduce what's going on, right? So can I reduce the square root of 9x? If you need to do it on the side, you can. That's the square root of 9 times the square root of x, right? Right? You guys still here? Okay, good. What's the square root of 9? Can I do anything with the square root of x? No. So that becomes 3 square root x. Square root 16? 4. It's a perfect square. That's nice. Now what would happen if this is not a perfect square? Then you're in a situation like this. This is called rationalizing the denominator. You might have to do that when you pull something out of a fraction. It's not always a perfect square down there. So you might have to do this as well. So in a nutshell, that's really the rest of the radicals. Are there questions?